Hi students, let's do a review of what we have learned last week. So last week, we have learned that these two main things, find general expression for n term, and check whether a number or term belongs to a sequence. So how this video will be like, will be in three parts. We do a recap of what we have learned last week, review some of the work, and lastly, for you to do corrections and improve on it. Okay, so for this video here, I break down into 4 steps whether you can, and so you can do a check yourself whether you can achieve these 4 steps or not. So step 1, are you able to recognize that for expression of n term, it can be used to represent any number or term in a sequence? So what does this mean? So let's look at a question here, question 7. So when we have an expression of n term, this means that this expression here can be used to represent 9, 13, 17, and 21 by replacing the n with 1, 2, 3, or 4. So this is what it means by using an expression of n term, and this n term right can be used to represent any number or term that belongs in a sequence. So this n here right, again at the bottom left of the screen now. So this n is actually represents the position of the term. What does it mean? It means that, for example, 9 is the first term of the sequence or the first number of the sequence. So 13 is the second number or second term of the sequence. So 17 is the third number or third term of the sequence. And 21 is the fourth term or the fourth number of the sequence. So when you say number, right? So if you see, so when I say term, right, it just means number. So the number of term in this sequence here, right, is 9, 13, 17, 21. So by writing out how does 13, 17, and 21 relates to the first term in the sequence, you can generally see the pattern here. And you notice that for every subsequent term after the first term, it's actually adding by 4. So now the thing we need to consider is how many 4 are we adding for the second one, for the third number, for the fourth number onwards. So you notice that the number of 4 that we add is actually taking the position of the term. For example, if I'm looking at the second term, so I take 2 minus 1. So I'm adding by 1 4, 1 sets of 4. So 9 plus 4 is 13. That's how I get my second term. And for the third term, also the same thing. I'm taking 2 sets of 4 plus 9. And for the fourth term, I'm taking 3 sets of 4 plus 9 to get 21. So this n term here, the expression of n term, is actually the quickest way to tell us what are the numbers that belongs to a sequence. So sometimes it can be very tedious to write from the first term all the way to the 100th term and so on and so forth. So we use an expression to represent every single number or term in a number sequence. So after you can recognize the expression is to represent any number or term in a sequence, we can use it to solve for part 3. Why? So in part 3, right, they tell us that the k term of a sequence is 153. So they ask us to find the value of k. So this k, right, is actually a position in the number sequence. So how do we find? So the step 2, it needs you to read the question and identify that actually 153 is a term or number in the sequence. So since 153 is a term or number in the sequence, we can just equate it. We can just equate the expression of k term as 153. So I write 5 plus 4k. So I use the arrow to point to you. 5 plus 4k equals to 153. So just by writing this statement down, you'll get 1 mark. Why? Because it shows me that you are able to use the expression of n term and equate it to 153. So since n is just a general variable to represent any positions, so now they tell us a very specific position, which is k. So just replace n with k only. So 5 plus 4k equals to 153. This is the equation. So this equation represents the k term. So I'm actually just rewriting 7 part 3 into an equation. So I'm rewriting it into an equation. So now all you need to do is to do step 4 to find the value of k by solving this equation. So if you are not familiar with solving equation, please revisit chapter 5 because you need it for the upcoming weighted assessment 3 in term 3. So by solving this equation, you're actually finding out the position of 153 in the sequence. Means, where is 153 located in this sequence? So you solve the equation and you found that k equals to 37. So this means that 153 is parked at the 37th position in this number sequence. So after you run through this question here, you do a quick run through whether which step can you achieve for these particular questions. So these steps here, right, give you allow you to see where can you achieve and how can you improve further, or what are the steps that you are, or what are the learning gaps that you need to focus on. So now let's look at an example. Okay, so let's credit to Jiaxuan for showing us this particular working so that we can learn from it and improve on it. Okay, so for this particular working here, right, this is actually considered a primary school method. Why? Because you are not using algebra for what you have learned in the past few weeks and use it to solve the equation. And let me tell you two disadvantages, that means the 2 bad points for using such method to solve 7 part 3. So the first disadvantage is whereby if you happen to transfer any number wrongly, right, you'll get 0 for the entire mark. There's no method marks for you. And number 2, since you're not able to show me the method marks to rewrite 7 part 3 into an equation, 5 plus 4k equals 153, you will not be given the full credit. That means you will not be given the method. That means even if your answer is correct, right, you at most get 1 out of 2 marks if this is a 2-mark question. So since now you are in secondary school now, take this chance to learn how to write an equation and solve it. Because when you go to Sec 4, right, for your N level, you'll need to know these skills in order to be rewarded the marks when it's being marked by your examiner. So don't use such method anymore. Okay, so let's look at question 8. So question 8 also the same thing. Similar question, similar concept. Just that now we are dealing with a different expression. Why? Because we are looking at a different number sequence. That's why the n expression will be different also. Okay, so these are some. So what Anissa is writing here, these are the steps to help you to start. Because sometimes when you see this number sequence, you might get afraid, you might get like anxious, don't know where to start. So by rewriting these numbers here, 1, 7, 13, 19, in the form of the first term plus something or times something, depending on what is the number sequence, by listing it out step by step, you can actually look and find out a rule or pattern for this particular number sequence. So when you can see a pattern already, then you can generalize it to form the expression for the nth term, which is 1 plus 6 times n minus 1. Why? Because I noticed that for the number of 6 that I add, it's actually one less than the position of the number in the sequence. So after that, you cannot stop here. You must go on to simplify. So you need to expand. So if you're not familiar with simplify expand, please recap previous chapter. So 1 plus 6n minus 6, you need to simplify further, and you'll get 6n minus 5. Okay, so let's look at part 3, part 3. So by writing this equation down, that means you rewrite the words into equation. You get 1 mark. Why? Because I know that the n expression or the expression of n term, it can be used to represent every number as long as they belongs in the sequence. And since the question tells us that one term in the sequence is 133, this already tells us that 133 belongs to the number sequence. So that's why we can equate it to the expression in n term. So 6n minus 5 equals to 133. So the question asks us to find the value of n for this term. That means asks us to find out this 133, right? Where is it located? Which position is it located in this number sequence? So we solve this equation, and after that we found out that n equals to 23. That means that the 23 number is 133. So you also use these same 4 steps here to check whether which step can you achieve for question 8. Are you able to achieve step number 1, which is to recognize that expression of n term can be used to represent any term or number in a number sequence? That's now step 1. Step 2, are you able to read the question and identify that 133 belongs to this number sequence? And are you able to achieve step 3 by combining step 1 and step 2? Why? Because since you know that expression of n term can be used to represent any number as long as they belong to a sequence, you can use this expression of n term and equate to 133. So in step 3, whether can you rewrite the information into an equation? And step 4, are you able to solve it? So these are the 4 steps where you can take note of yourself, and whichever step that you cannot achieve, don't worry. This tells you that these are your learning gaps and you just need to work on it. Okay, so all the workings here are nicely done. So I will mark 1 mark, method marks, for writing down this equation. That means you rewrite the information into an equation, 1 mark. So this equation represents the expression for 133. That means we equate 6n minus 5 to 133. That's the method marks. So once you simplify and solve it, and you found out that n equals to 23 correctly with all the steps needed, you'll be given the second mark if this is a 2 mark question. So this one will be 2 marks. So please look at the second video to take a look at the second learning point for last week. Are you able to check whether a number or term belongs to a sequence? Okay, so for this one, for the second learning point, we also use the same 4 steps. Just that instead of telling you that this number belongs to a number sequence, now I tell you that let's test whether this number belongs to a number sequence. So the steps are similar. So we need to watch the second video to find out how are they similar and how can you apply the 4 steps above to solve such questions. Thank you.